Let's talk about solving radical equations. And by radical equations, what we mean is equations where the thing that we're solving for, in this case, x, is under a radical sign. Now, in this equation, there's also an x that's not under a radical sign, but because there is an x under a radical sign, this is a radical equation. And these are the four steps that we're going to use to solve radical equations. Basically, we need to get x out from under that radical. And so the first couple of things that we need to do are we need to get this radical by itself, and then we need to square both sides so that there's no radical anymore. So let's start with those two steps. We can add 1 to both sides. That'll get the radical isolated. And then we can square both sides. So squaring just cancels out the radical sign. Pardon me, I didn't write squared here. And recall that this actually means this. So we need to FOIL, but we'd end up with x squared plus 2x plus 1. So what we have now is a quadratic equation, and we know how to solve those. Get everything equal to 0. So I'll start by subtracting 5x from both sides and subtracting 11 from both sides. So that'll give us x squared minus 3x minus 10 equals 0. And now we can solve by factoring. So x minus 5, x plus 2. So things that multiply to negative 10 and add to negative 3, that would be negative 5 and positive 2 equals 0. And then 0 product property, we can set each of these factors equal to 0, but I'll shortcut straight to the answers here. When you are solving radical equations, and in general, whenever you square both sides of an equation, you must test for extraneous solutions. Why is this an issue? Well, we could take a statement that's very clearly not true, and if we square both sides of this, well, we end up with something that is true. But the original statement that we started with was not, in fact, true. So squaring both sides of an equation can result in answers that look to be true, but in fact are false. We always need to test these. And we had a couple of situations where extraneous solutions came up in first semester. Remember, when we're talking about checking for extraneous solutions, this is not, let's check our work and make sure we did it right. This is the correct process of solving certain types of questions can give you answers that are not, in fact, solutions to the original problem. Okay, so let's test these. Let's start with x equals 5. And remember, we've got to put these back into the original equation. So square root of 5 times 5 plus 11 minus 1 equals 5. Let's see if this works. So 25, 36, 36 minus 1 equals 5. So that's 6 minus 1 equals 5. 5 equals 5. Okay, good. That means that this x equals 5 is in fact a solution. This gave us a true statement. Okay, let's check negative 2 now. And an important note here is that it's not going to be always, oh, one works and one doesn't. They might both work. They might neither work. It might be that one of them works. We always need to test both of them. So let's try x equals negative 2 now. So again, I'll plug that in. 5 times negative 2 plus 11 minus 1 equals, we're testing negative 2. Okay. So that's negative 10 plus 1 is 1. Minus 1 equals negative 2. Square root of 1 is 1. Minus 1 equals negative 2. 0 equals negative 2. Well, that's false. That does not work. And therefore, x equals negative 2 is not an actual solution. This equation only has one actual solution. It's x equals 5. So those are the steps. Let's apply them here on another example. Square root of 2x minus 2 equals x minus 1. In this case, the radical is already isolated, so that first step is taken care of for us, and we're ready to square both sides. I'll do it like that. Okay, again, squaring and the radical cancel each other. And this, again, I'm going to shortcut, but remember, if you need to, this is write it out, x minus 1 times x minus 1, FOIL, etc. But that'll be x squared minus 2x plus 1. And it's a quadratic again. Most of these will end up being quadratics if you'll have something like this. Okay, minus 2x. So we get x squared minus 4x plus 3 equals 0. Same deal, factor. And we'll call them possible solutions. And let's test them. So we'll start with x equals 3. So root of 2 times 3 minus 2 equals 3 minus 1. 6 minus 2 is 4. 3 minus 1 is 2. And the square root of 4 is 2. So we are good to go on x equals 3. And let's test x equals 1. Equals 1 minus 1. And let's see, square root, okay, 2 minus 2, square root of 0 equals 0. Yeah, 0 does equal 0. So in this case, both of these work. They are both solutions. Like we said, these solutions could both work. They could neither work. Maybe one of them works. We always have to test all of them. Now, here's a slightly different kind, because here there's not just one radical, there are two radicals. And this is going to require us to do 2 rounds of isolating and then squaring. And here's what that's going to look like. So I'm going to isolate this radical first. I don't know why, it just looks more complicated, so maybe I'll get it out of the way first. So I'll add root x to both sides. And we'll get root x minus 4 equals, and I'll just flip the order of this, root x minus 2. Okay, so we have one radical isolated. Square both sides. Okay, here the radical and the squared cancel. All right, I'm going to write this out just to make sure that we do this correctly. Root x minus 2, squaring means multiplying it by itself. Okay, and let's FOIL. Root x times root x is x. Outside, minus 2 root x. Inside, minus 2 root x. And last terms, plus 4. So we can combine those middle two. Okay, so I'll put that back in here. All right, so there's a little bit that we can do here. We can subtract x from both sides. That's useful. Gets rid of one variable there. And since I have the radical term over here, I'm going to get rid of I'm going to subtract 4 from both sides like that. Okay, so x minus x. Okay, so this is negative 4 minus 4. That's negative 8 on this side. X minus x, that's gone. 4 minus 4, that's gone. And I get negative 4 root x over here. Okay, I want to isolate now this radical. Divide both sides by negative 4. And I get root x equals 2. Square both sides. And we get x equals 4. If we have a radical equation, whatever answer or answers we get, we need to test to see if they actually work. So we only have one to test here, but we need to try it. So root of 4 minus 4. So I'm just inputting x equals 4 that we just got into this line here, our original equation, minus root x, which is now 4, equals negative 2. Remember, a single radical can't equal a negative. If we just have, root x equals negative 2, that's no good. But that's not what's going on here. This is 2 radicals subtracting to potentially equal a negative. That can happen. So let's see if this does actually work. Okay, root of 0 minus root of 4 equals -2. Okay, that's 0 minus 2 equals -2. And yeah, -2 does in fact equal -2. That works. And so x equals 4 is a valid solution. And one more note on something that you might see here. It could actually come up on a simpler type of question. Let's say we have something like this. So we'll do our first step here to isolate the radical. -6 minus 6 root x plus 3 equals -4. Well, we could go through the whole process here, but we really don't need to. The square root of something cannot be a negative. If we see this, square root of something equals a negative, that's easy. There's no solution. And just as a reminder on some of our definitions here, if we just have root 9 equals x, then x equals only 3. That's different from saying x squared equals 9. Take the square root of both sides. Remember, when we take the square root of both sides is when we need to include a plus and minus. So that's different. If you just have x equals root of something sitting there by itself, we're only talking about the positive version. So that's solving radical equations. And these are the basic steps. Isolate the radical, square both sides to get rid of the radical, solve, and then always, 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 with radical equations, we have to test for extraneous solutions. And if we have an equation with two radicals in it, we isolate one, square both sides, then isolate the other, square both sides, and that should get us to our solution.